Okay, now we are going to talk about concentration and pressure. So let's look at the following reaction. Let's analyze what we have. We've got hydrochloric acid, calcium carbonate, carbon dioxide is given off, and we collect that in the gas syringe. There you go. That's going into there, isn't it? And then we plot the volume of carbon dioxide on the y-axis against time. Now, as you can see here, we're going to play around with the concentration of the acid. First, try and write an equation for the reaction. Now remember, you can stop the video while you do that. Don't get stressed. Okay, so the reaction is carbonate plus acid gives salt plus water plus carbon dioxide. The salt is calcium chloride. Formula CaCl2. So I'll leave the rest to you. Here we use an excess of the acid, and the calcium carbonate was the limiting reagent. Now that's important here because that explains why the graph, the total volume of carbon dioxide given off, is always the same, because you've got the same amount of calcium carbonate, so there's a fixed amount of carbon dioxide that can be produced, and the only thing we're thinking about is how fast it's produced. We have to talk about successful collisions here. Successful collisions. So what happens when the concentration is increased? Well, you have to fill this space in now. Let's have a think about this. Concentration means greater number of particles per unit volume. If there's more particles, there's more collisions. And if there's more collisions, then there's more successful collisions. It's about probability, isn't it? So here, greater collision frequency means more successful collisions, means faster reaction rate. If we talk about gases, then the pressure of the gas is the same as the concentration. So if I increase the pressure, I increase the collision rate. Temperature. We know that temperature increases the rate of a chemical reaction, but why? At low temperature, particles move slowly. At high temperature, they move faster. So what happens if we increase the temperature? The particles have more kinetic energy, they move faster. What will this do to the collision frequency? It means that they will collide more frequently, more often, which will increase the number of successful collisions. But also, and this is more important, what will the collisions have much more of, and what will they be able to overcome much easier? So remember, for particles to react, they have to collide, and they have to have enough energy to react. And that's the key. They must have, or they've got more energy at a higher temperature, which makes a reaction much more likely, more probable. Let's have a look at this following experiment. Magnesium reacts with hydrochloric acid at two different temperatures. Now look how we control the temperature. We have what's called a water bath, a thermostated bath, a trough of warm to hot water, so we can control the temperature of the reaction. In here you've got magnesium and hydrochloric acid. I'll let you write the equation. The gas produced here is hydrogen, and we can do the reaction at different temperatures, and we can look at how the temperature affects the reaction rate. This is a similar kind of thing. So the volume of gas produced and the time. At a low temperature, you get a curve that looks like this. At a high temperature, you get a steeper curve. Remember, gradient gives reaction rate, so the gradient here is greater. And then, because you're using the same amount of reactants, then you get the same total volume of gas. How can we explain this? Well, we've got to talk about activation energy. At a higher temperature, many more particles have have an energy greater than the activation energy. They've got enough energy to get over that hump to make the products. It's all about activation energy, which is why temperature is so important in reactions. Great, that's the basics. Have a go at the textbook, read the pages, and try the questions.